Hi all, I'm here to show you how you can use MFIT to discover and collect your AWS workloads. To start off with, let's just check we're working from a clean MFIT DB, and we can do that by running MFIT discover ls. This will list all my MFIT assets, and as you can see, there's nothing there. We've got a nice clean DB. Okay, now let's start performing inventory collection against MFIT, against AWS. To do that, we can run mfit discover AWS. It's going to ask me for the region. This time it will be EU West 1. And my access key ID and access key secret. If you don't have any, you can set them up on AWS. There's lots of documentation out there on how you can do that. I've already got mine ready, so let's enter them. Now these are secrets, so make sure to keep them secure. MFIT doesn't store them anywhere, so should be quite safe. Okay, we've now collected information using the AWS APIs about all the VMs in AWS in this region. Let's list them. Okay, here. There's lots of VMs here. This only collects sort of summary data about the VM. We haven't run any collect script on the VM itself, so we don't know information about what's actually running on it. But what we do know are things like its OS. We know what size it is, how much memory it's got, how much storage, how many CPUs it's using. So all this information is really valuable for assessing its ability to move to Google Compute Engine, for example. It isn't enough if we want to actually containerize this VM, or if we want to containerize some of the workloads on the VM, like maybe Tomcat or JBoss might be running on this VM, and we won't be able to detect that using this. So in order to detect that kind of thing, we need to run a collect script on the VM itself. Unlike inventory collection, there's no one-stop shop way of doing that. We don't have an inbuilt command in MFIT to collect it, and the reason why is because it probably depends on your exact setup. You probably have some way of managing your AWS VMs, and it's best if you use that to run this collect script. For example, one of the inbuilt solutions that AWS provides is Session Manager, and it's fairly easy to set up, although it's available for most OSs, although not all in AWS. So assuming you've got it set up, we've got some scripts and guides which show you how to use it to perform collection. We've also got the guide also shows you how to do the same using SSH and also Terraform as well. So the point being, however you usually manage your AWS VMs, then use that to actually run this collect script. So now I'm going to follow the guide. The first thing you have to do is download this collect script and make it executable. So I'm just downloading a script from GitHub and making it executable. And now I run the script and I provide it a region. So we're just running the script, and we provided the region EU West 1, same as before. Okay. So as you can see, we're now going to collect all the VMs one by one. This works for Linux and Windows, and it's now completed. So we've collected a whole bunch of VMs, and now if we run mfit discover, a couple of them failed for whatever reason. For example, in this particular case, one of our VMs is an Active Directory domain controller, and AWS doesn't allow you to connect to an Active Directory domain controller because it's not secure to do so. But that's fine. I think that's probably a good thing. All right, let's run mfit discover ls. And this time you can see that some of the VMs have guest Linux data. That means we don't just have the API level data from that AWS provides us. We've also got this collected data. And now that we've collected all the data we need, we can run mfit report format. There's a bunch of different formats here. This time we'll go for the HTML report because it's the prettiest. Let's go for the full report and write it to downloads AWS report.html. Okay, great. So I've now opened the fit assessment report, and as you can see, the first page we land on is a dashboard. This contains a high-level summary about everything we've collected. So, for example, an OS breakdown, and then a breakdown, so we've got 203 VMs, of which 195 are Linux and 8 are Windows. And then we can see, for each of those journeys, how many of them are suitable for Windows and how many of them are Linux. So, for example, containerize only as Linux VMs, whereas the shift journey is 181 Linux VMs and 8 Windows VMs, and then the rest, aren't suitable. Okay. We can also see here the breakdown for each journey. We have 27 VMs which are good fit for containerized, 9 require effort, 9 are no fit, and the rest are insufficient data. The reason they're insufficient data is because we weren't able to run guest collection on those VMs. Here we can see the list of all VMs, and we can also filter. So, for example, I might be interested in only those which we can containerize. So I can open this one, and okay, it's Ubuntu VM was on. We managed to perform both guest collection and inventory collection on this VM. Now let's see. Okay, so we can see it's a good fit for all the journeys. But there was one rule that we couldn't evaluate because we were missing data about the SE status of this VM. It's not a problem. We can look at some other things. We're missing data about disks for this VM as well as some other things. Okay, but overall, it's a good fit. We can also look at some VMs which might not be a good fit for everything. So this VM, for example, we can see we don't have any guest data. The reason we don't have any guest data in this case is that the VM was off. So there's no way we can perform guest collection to an off VM. And therefore all the containerized journeys have this question mark, which means we don't have enough data to assess them. But we can also open here. It's an ARM VM, So an ARM VM we don't support, and so it's no fit. All right. That's about it.